Right, if f of x equals the square root of x plus 2 divided by 3 minus 3x squared, find x if f of x is strictly greater than 0. We proceed to write the solution to this problem as follows. So first things first, we have that f of x is actually equal to x plus 2 divided by 3 minus 3x squared, and we have the square root, like so. Moreover, we have that f of x, which equals the square root of x plus 2, you divide by 3 minus 3x squared. Okay, this is strictly greater than 0. Okay, so if this is greater than 0, two things here are extremely important because this one is of the rational type. So what we have is that the numerator x plus 2 is strictly greater than 0, and the denominator 3 minus 3x squared is also greater than 0. Right, now this square root being strictly greater than 0, a couple of things can be done, but most importantly, it follows that x plus 2 is greater than 0 either way, so that x is bigger than minus 2. Simultaneously, we can divide through by 3 here. We can divide through by minus 3, getting x squared minus 1 is negative. Okay, because if you divide by a negative number, the inequality changes direction. Right, we factorize and we have x minus 1 into x plus 1 is negative. Okay, now let's look at this very, very carefully. At this point here, we're able to get what we call the critical values. Critical values. What are the critical values? Right, the critical values are two of them. They're 1 or minus 1, like so. And so with this said, we proceed to solve this problem. So we have seen that we have x bigger than minus 2, and we have the critical values. Right, the critical values, x equals 1, minus 1, or x equals 1. Now, what is the meaning of this? Remember, these are the critical values together with this inequality here, x minus 1 together with x plus 1 is negative. And what we do then, we put the x minus 1, we put the x plus 1, like this, and we draw the real number line. Let me just draw a line that looks a bit more straight here. Right, so we draw a real number line like so. And we have here minus 1 together with 1, and these are the values of x. Okay, real line of the values of x. And so now you can extend like this here. Furthermore, extend like so. Right, any number smaller than minus 1, maybe you can pick minus 2. Minus 2 minus 1 is minus 3, so the result will be negative irrespective of the choice of the number. A number strictly less than minus 1 can be like a minus 2. Minus 2 plus 1 here will be negative. And here we have x minus 1 into x plus 1. If you multiply the two, you have a positive. Between minus 1 and 1 is a 0. You can choose a 0 or any number between them, but 0 is easier. 0 minus 1 is negative. 0 plus 1 is positive. Multiplying them is negative. Now, bigger than 1, maybe a 2. 2 minus 1 is positive. 2 plus 1 is positive. Multiplying them is positive, like so. And so what we have we require is that this must be strictly negative so that -1 is less than x less than 1. Okay, so we have that this is the case. So we have that together with the fact that x bigger than -2, and this is the case. So the conclusion then becomes that what we have is that x is bigger than -2, and -1 is less than x less than 1. And we need to graph this on the real line. If you graph this on the real line, we put here, for example, -2, we put here -1, we put here 1. We actually therefore connect these points like so, and then we have here x bigger than -2 strictly, and we have this. Right, so now as a conclusion, we are really saying this inequality and this should overlap. And where do they overlap? We can see that they overlap here. And the conclusion is therefore that hence we have that -1 is less than x less than 1. Right. And obviously we understand that at this point x is an element of the set of real numbers. Thus f of x equal to the square root of x plus 2 divided by 3 minus 3x squared is strictly greater than 0. This implies that -1 is less than x less than 1, where x is an element of the set of real numbers. And we've solved this problem in detail. Thanks everybody for your time and attention. And we've got this right, and goodbye to you.